So here's our goal for today. We are going to talk about adding and subtracting polynomials. And then for the rest of the unit, if you look at your calendar, we're going to be multiplying them, dividing them. By Thursday, it's going to start looking like Algebra 2, all right? And so that's when it's going to kick up several notches. When is your first quiz for the semester? Monday. And look at your calendar. Is there any test for this unit? No. These are like really basic skills setting us up for the next unit. So we're just going to quiz on it and then move on to the next stuff. How many of you are graduating this semester?
I'm graduating after this.
Y'all, this semester is going to go so fast. You're not. When it's time to graduate, you're going to be like, we just got back. Happy New Year. Thank you. Okay. So a few things. All right. So let's begin. Math. I'll probably apologize. I always make bad jokes. I always go, well, I don't know. How am I supposed to know? I don't know what children do. Sometimes. All right. So here's what we're talking about today. Polynomials, but we're going to start by reviewing some definitions, and you're going to get kind of bored real fast, and you're going to be like, why is she telling us this? And the reason is because they're so simple and so basic, they're easy to forget what they mean. So we're going to spend a few minutes talking about them. A constant is a number that's all by itself with no variables attached. So give me a number with no variable on it. 9, -3. Give me a decimal like that. 0.5, 1.1. Okay, stuff like that. I know I always ask an open question and 3 people answer. I don't really understand what any of them said. And then people get mad that I didn't get their number right. Or they get mad because I accuse them of doing drugs or something. I'm always making people mad. Term is a constant or, oh, I did just record that. So. Yeah, or a constant times a variable, okay? So all of those are terms, like 9 is a term, but if you attach a variable to it, still a term, right? Like if you had 9m, or maybe you have -1.1 x cubed y squared, also a term, okay? That's also a term. Now, this is one term, this is one term, this is one. They're all separate from each other. And notice that there's no addition or subtraction inside there. Those are all multiplications. So as long as it's multiplication only, you can call it a term. Once you put an addition or subtraction in there, like let's say you combine these like this. Now you have 2 terms being combined by addition or subtraction. This is a polynomial, okay? It's multiple terms being combined with either addition or subtraction. Okay? This specific one has 2 terms, so we call that a binomial, right? Just one term, like just the 9m, that's a monomial. And if you had 3 things, it's a trinomial, okay? Okay, so like terms are things that have both matching variables. The variables in the term are exactly the same, but also the exponents on them are exactly the same. And in that case, you can actually do addition or subtraction on them. So for example, here, I can't do 9m minus 1.1 x cubed, blah, blah, blah. But I could do math like this. If I had 5x cubed y squared minus 1.1 x cubed y squared, I could do that math. Because not only do they have all the same variables, but the variables have all the same exponents. They have to match exactly before you can add or subtract them. Now tomorrow we're starting to multiply. And the rules are different for that. All right, but for addition or subtraction, that's the rule. So but by the end of the unit, that's going to be the hard thing, is keeping those rules separate. When do you change the exponents, when do you not? So be careful about that. So down here we have all this stuff, and we're going to find the ones that match, and we're going to combine them with addition. So Give me one thing out of there, and then we'll see what matches it. Z? Okay. Does anything match with the Z? Why do I? They don't match, but here's what we can do right now. Let's talk about all the things that don't match anything. Z doesn't match anything. M doesn't match anything. What else doesn't match anything? 4ab squared. So we did, like there's no like term with it. There's nothing that goes with it. Like there's nothing that's just Z, M, 4ab squared. Anything else? Okay, so this is important. So when I said we're going to combine them, what would happen if I try to combine those, even though they don't match? They're not like terms. That's it. It's a polynomial. You can't. It is a trinomial. You can't do anything, right? That would just be the answer. You would stop right there. Give me another thing. No, I think we got all those. This one, 5xy squared. I heard some. Okay, so 5xy squared matches with negative xy squared, so I'm going to add that, and positive xy squared. So now here's the thing. Yeah, so these cancel. So what's my answer there? 5xy squared, okay. So give me something else to start with. 3x squared y, okay. So 3x squared y, what do I have that matches that? The 2x squared y, the negative x squared y here. Okay, now something I want to say about this one. Now on the green one, stuff canceled, and it was candy, right? It was no big deal. But on this red one, nothing's canceling. So here's the rule I need you to understand about adding or subtracting polynomials. You only do the math on this part. The powers are not going to change. So it's like you're saying, look, I have 3 of these x squared y's. I have 3 of them. I'm going to add 2 more, and I'm going to take away 1 of the x squared y's. 4x squared y, without changing the exponents at all. So for addition or subtraction, the powers stay the same. And this is we did do some rules of powers and exponents last. Yep, exactly right. What else? What do we have left here? What's our vocabulary word for 9, negative 3, and 4? Constants, right? Good. Thank you. What is 9 plus negative 3 and 4? 10, right? Okay. I know you know how to do that. We were just practicing finding like terms and adding them. Okay. So that was just like a little review of stuff. We're going to make it more mathy now. So number 1 says find the sum, and you have these 2 sets of parentheses with polynomials inside, and you're just looking for like terms that you can combine. They're set up pretty easy for you, like in the same order and everything. What can I combine with the 7y squared? 4y squared. So is that 11y squared, or is that 11y to the 4th, or what? Right, okay. So what combines with negative 2y? Okay. Yep. And then the 9 and the negative 7? My daughter is 14, and her friends are so ruthless, we had to actually check in with my daughter, like, are you making your friends mad? Like, did they get mad? Because we'll hear her on the phone, and she's like, no. And then I had them all in the van the other day. I was taking them somewhere, and I was like, y'all are so mean to each other. I was like, middle school thing? Yeah. I know, that's what I thought. Okay, that was a little break. Back to math. What do I have to do here before I can start?
Or find the like terms, right?
Before that even.
Oh yeah, you have to distribute.
Assess the situation and distribute the negative, right? If there's a negative in front of parentheses, you have to bring it through because you're subtracting everything in there. So it becomes minus 2w squared, and then minus negative 4 is plus 4. Okay. So now just going left to right, what can I combine with 9w squared? What kind of 2? What kind of 2? Negative. What can I combine with the negative 7w? Nothing. So just bring it down. What can I combine with the 5? The positive 4. It's positive now, right? All right. Does anybody need this up anymore before I change it? Okay. Oh, what is this, do you think? It's a trinomial or a polynomial. They're so cute, right? Do you have gnomes in your guys? Do you have? We don't want to turn and talk because it's the first day after break and ain't no one going to do that. All right. These three things go together. Number 5 is really our goal, but if I just gave you number 5 cold, you'd all get it wrong. So we're going to start out slow. Look at number 3. It says when 5 is subtracted from 9, what is the difference? What would you tell me is the answer there? 4, right? When 5 is subtracted from 9, the answer is 4. But what's the actual math that you do? Like, give me the 9 minus 5. Write that down on your paper, 9 minus 5. Oh, we're working up to number 5. Here's the thing. If you're not being careful, what do you think? So this was easy because it was regular numbers. But if it gets weird like number 5, here's what students do. They say, okay, it's asking me to subtract. I'm going to take this thing minus the second thing. But is that what we did here on this easy problem? No. We did not do 5 minus 9. See, the 5 is first, the 9 is second. It's easy if you're not carefully thinking that that's just the order you subtract them. But you'd be wrong. So don't do that, okay? So number 4, which is like middle kind of a problem, should I do 3x squared minus 9x squared, or should I do 9x squared minus 3x squared? Yes, because it's saying when that is subtracted from that one. So you just have to sort of slow down and think about what the words are asking. And one good skill for math, like let's say you go off to school next year and you're taking a math class and you get a word problem that seems kind of hard. If you're looking at something like this, number 5, and you're like, I don't know. If you can just substitute in easier numbers, like whole numbers, and just take a minute and think about, okay, how would I do this problem if the numbers were easy? Figure that out like we did on number 3, then you can use that as a model for the harder, weirder problem. All right, so always remember that you can do that. So then anyway, on 4, what is 9x squared minus 3x squared? 6x squared, good. So number 5 is the real problem, and we just worked our way up to it. 2x squared plus 5x minus 7 is subtracted from x squared minus 4x plus 9. Which thing are you writing down first?
X squared minus 4x plus 9
okay.
minus 2x squared plus 5.
Okay, so I like this. This is what I heard you say. Yes, what are you saying? Was that Talia? That's right. We need parentheses because the way I've written it here, I'm only subtracting the what? The 2x squared. But I need to subtract the entire thing. So we put parentheses here to show that it's a group of stuff. Bless you. Bless you. I'm not recording all this time? Oh, okay. And then distribute the negative, right? So it becomes plus here, and then everything inside gets opposite signs because you're subtracting them. So minus that one, minus that one. What happens to the 7? It becomes positive. So what combines with the x squared? Okay, which is negative. So I've got one of these. I'm taking away 2. I'm left. So what does that give me? Negative 1. Do I have to write the 1? Nah, I don't have to write it. We understand that it's there. How'd you get that? Which one? Yep. Negative 4x, negative 5x. And then 16, the 9 and the 7, right? We are almost done. We are done with that part. All right, number 3, find the perimeter of the triangle. What does perimeter mean to do? Do what with them? Add sides. So we've got, give me one of the sides. Plus, and what's another one? What's another one? All right, so what are the like terms here? What's something that combines? The A's, how many are there altogether? 4 A's. 1 here, plus 2, plus 1 more. What else combines? 2, right? So we have the negative 1 plus the 3, so that's a plus 2. And then what are my units? Inches. So look at how this is written. And tell me why you think I would like for you to do this. Why? Why would I like that?
Because that's like all shapes.
It's a binomial, it's a polynomial, and it means that the inches goes with the entire thing, not just the 2. I'm not going to count off if you don't put the parentheses, but I just, in my professional opinion, you should put them. All right, try number 4. Oh, I hate that. I hate easy peasy lemon squeezy. Which one did you get?
I got the second one.
Second one? The correct one? Did anybody get the first one? 14x minus. That's interesting. I don't think that's correct, but it's close. What mistake? So this one's wrong, but what mistake did I make?
Oh, you only added only 2 sides.
I only added 2 sides. Perimeters, all of them. And what do you know about opposite sides on a rectangle? They're equal, so you need 2 of these, which is 6x squared, 2 of these, which is 8x squared minus 16, and then you add them. Don't forget your units. Now, if you need the bathroom, you may go, or if you want your phones, you may have them. I'm leaving the practice worksheet for tomorrow. Okay?